Hello and welcome. We're starting with Section A.6, so this is for those of you with a physical copy. This is in the back of your book, Appendix number 6. Just a quick review on some key skills in solving equations. So we'll just do sort of a quick little mini review of some of the key types of equations that you need to have under your belt before you start this course. So we'll start with rational equations. So we'd be asked to solve something, for example, the form the reciprocal of the sum of x and 2 increased by 3 over the difference of x and 4 is worth 2 over the quantity x squared minus 2x minus 8. On this, recall that division by 0 is undefined. The left-hand side is already as factored as it can get. The right-hand side, however, we can do a little bit of factoring there, and they were nice to us on this one. They gave us a quadratic that factored into the other two factors. So here we have two excluded values that are outside of the domain of this problem. So x cannot equal -2, x cannot equal +4, and of course we're assuming x is in the set of reals at the moment. We will eventually expand to complex as well. So here our LCD would be x plus 2 by x minus 4, so we just multiply everything by the LCD. And since we stipulated that x is not worth -2, x plus 2 divided by itself is worth 1. And 1 times any number is that number, so those will drop. We've also stipulated x is not worth 4, so x minus 4 over itself is also worth 1. And same kind of thing happening on the right-hand side. There's a couple of 1s. So we have difference of x and 4 plus 3 by sum of x and 2 is worth 2 by 1 by 1 is just a 2. So this guy turned linear, so we have 4x, let's see, minus 4 and plus 6 is worth 2. So 4x plus 2 is 2, so 4x is 0, so x is 0. And that is not one of our excluded values, so we do get to keep that in our solution set. If you don't list excluded values for this type of problem, then your other alternative is to do a check substituting that into the original everywhere you had an x and simplifying until you have one number per side and confirming that it does indeed work. Excluded values, of course, the sort of quicker way to get there, though. And we also have quadratic equations. We do quite a bit with that still. So, a few different methods. First method that you learn, likely in Algebra 1 or even sooner. So quadratic, of course, generic format, ax squared plus bx plus c is 0. A is, of course, non-zero. A, b, and c in the set of reals. Again, we'll expand it to complex later on as well. A has to be non-zero, otherwise we're looking at a linear. 0 times x squared would be 0. 0 plus any number is that number, and we would have bx plus c equals 0, which would be, of course, linear. All right, so factoring, as I mentioned, the first way that you learn to do these, so we set one side to 0 and just turn it into a multiplication problem. So we're looking to multiply to 1 by 15 is positive 15, add to negative 8, so negative 3, negative 5 will do both jobs just fine. So either x minus 3 is our 0 or x minus 5 is our 0. Since that's the only way we have a multiplication problem ending in 0, one factor or the other had to be worth 0, otherwise our product can't be a 0. So x could be 3 or x could be 5. And here, basic polynomial, we don't have the domain restrictions that we had with the rationals. We don't have to worry about dividing by 0. So there's our solution set, those two real numbers. We also have the square root method. We have x squared minus 9 is 0. You, of course, know by factoring that we would have two different answers to that, negative 3 or positive 3. So in the square root method, we just add 9 to both sides. X squared is worth positive 9. Take the square root of both sides. You must include a plus or minus when you introduce a square root to an equation that did not have one before, and it goes on the side with the constant. So x is plus or minus 3, and there's our two solutions. This is an often forgotten step. It will end up costing points if you forget it. So yes, even on that first step, when you do it on both sides, it does have to be there, the plus or minus. Otherwise, you're just looking at one of the two solutions. Occasionally, there's more work to do on that. They might give us like an x plus 7 quantity squared is worth 16. We can still solve that using that same nice, neat square root method. Square root of both sides. And x plus 7 is plus or minus 4. So x is negative 7 plus or minus 4. And then there is still a little bit of cleanup work that we can do. We can turn those into a pair of integers. So x could be negative 11, or x could be negative 7 plus 4, negative 3. So two different possibilities there. Both would still work. Still under the umbrella of quadratic equations, we have completing the square. If you're not super comfortable with this one, spend a ton of time practicing it until you are. This is a very valuable, very important tool in this class, and really in most of the math classes you'll have for the next couple of years anyway. Very handy tool. It comes up in a lot of places. So we'll start with just an x squared plus 8x plus 1 is 0. So the idea is to make it look like one of those other problems we just did. So I'll move that one out of the way. Some things I'm looking for in completing the square. An unwritten coefficient of the implied positive 1. When that's the case, then I take half of the middle coefficient and square the result. And that's what we'll add to both sides of the equation. So now left hand side we've got x squared plus 8x plus 16. Right hand side we have 15. And notice the left hand side is now x plus 4 quantity squared. X plus 4 by x plus 4, FOIL it out. You'll see that it does check out. And that little shortcut does work in general, that whatever is in here is your second term in the perfect square. So then same method as before. Now we're back to that square root method. So x plus 4 is plus or minus root 15. So x is negative 4 plus or minus root 15. So two solutions there. Not in the set of rational numbers. That's okay. No problem with that. We'll do just a couple more on completing the square, and then we'll get the quadratic formula under our belts. So we'll do an x squared plus 11x plus 2 is worth 0. So I still have the leading coefficient of the implied positive 1 that we're hoping to see. So I'll go ahead and move that 2 out of the way. X squared plus 11x, we'll leave a little space there, equals negative 2. So then my little thought bubble off to the side here. So I want half of 11 and to square the result. So $1.21 over 4. And I'll add that to both sides. So left side is x plus 11 halves quantity squared. Right hand side we have negative 8 fourths plus 121 fourths. So x plus 11 halves quantity squared. Excuse me. 113 fourths. And from there, square root both sides, plus or minus on the side with the constant, etc., etc. So x plus 11 halves is plus or minus root 113 over 2. So x is negative 11 halves plus or minus root 113 all over 2. And you can see that either as two fractions or with the common denominator. Okay, and for our last completing the square, for the moment anyway, we'll take a look at solving 3x squared plus 6x plus 1 is 0. Like the other problems, we'll start with moving the constant to the other side. The one giant red flag on this one, we don't have the nice, neat, pretty leading coefficient of 1 that we wanted as the other ones had. So we'll divide both sides through by positive 3. It is known as dividing both sides. You don't divide an equation by it, you divide both sides of an equation by it. So we have x squared plus 2x, leave a little room, is negative 1/3. And from there we can complete as usual. So half of 2 and squared, so 1 squared. So we will add 1 to both sides. I'll think of 1 as 3/3 for that side. So x plus 1 quantity squared is 2/3. And square root of both sides, etc. So we're back into the square root method from there. I'll take the liberty of splitting those guys up. So x plus 1 is plus or minus root 2 over root 3. And we'll go ahead and rationalize that denominator as well. So if it's been a while since you've done that, go ahead and give that some practice as well. So either x is negative 1 plus or minus root 6 over 3, or you might see it as x is negative 3 plus or minus root 6 over all over 3. So think of that as negative 1 over 1 and getting a common denominator going. Okay. So then another common method to quadratics, of course, is the quadratic formula. Now, something that you likely didn't do very much in your previous courses is actually construct proofs of how things work, why they work. And the farther you go in math, the more heavily we are going to be relying on proofs. So this one is just going to be a construction. You don't have to know too much about proofs to be able to just sort of follow this guy. So we'll start with a generic ax squared plus bx plus c equals 0. We're going to make the same assumptions we did previously. A is non-zero, a, b, and c are in the set of real numbers. So we'll kind of follow the same pattern we did with the last problem. We'll move the c to the other side. we don't necessarily know for sure that a is worth 1, so we'll divide both sides through by a. So then x squared plus b over a times x is worth opposite of c over a. If you look back at your notes on the last one, after we did that, got this nice, neat, pretty 1 as the leading coefficient, then we did half of the fraction, or half of the coefficient. Well, half of b over a would be b over 2a. If you want it half the size, double the denominator. And we square the result. So b squared over 4a squared is what we will be adding to both sides. So left-hand side will factor, so x plus b over 2a quantity squared. Right-hand side, go ahead and get a common denominator going, which would be 4a squared. So the minus c over a, I'm going to have to multiply that by 4a top and bottom. Second one already has the 4a squared, no problem there. So x plus b over 2a quantity squared is worth b squared minus 4ac over 4a squared. So I took the liberty of multiplying this part out. Negative 1c times 4a is negative 4ac. And just to cut down on our writing a little, we put the positive out front. Instead of having a minus and a plus, we just need to write the minus. Okay, so perfect square equals constant. So remember, a, b, and c are just real numbers. This side is just a constant. Square to both sides. Plus or minus on the side with the constant. So left-hand side, x plus b over 2a. Right-hand side, plus or minus square root of b squared minus 4ac over square root of 4a squared. Square root of 4a squared, 2a. So x is opposite of b over 2a plus or minus square root of b squared minus 4ac all over 2a. And of course they have a common denominator there. So opposite b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So this is actually a construction of the quadratic formula. So this is actually proving the quadratic formula. Alright, so just real quick, we'll put that to work for us. So we'll try out, let's see, maybe a 2x squared plus 7x minus 1 is 0. So x is equal to opposite of b, negative 7, plus or minus square root of b squared, so 49 minus 4 from the formula. Now you know where that minus 4 comes from, that you likely saw before but hadn't seen proven. So minus 4 times a times c, all divided by 2 times a. And we go from there. So negative 7 plus or minus square root of, so we have 49 plus 8 all over 4. So x is negative 7 plus or minus square root of 57 all over 4. And 57, let's see, we can factor 3, but I don't think we get any perfect squares out of it. No, 3 and a 19, no dice there. So that would be our set of perfect solutions. 2 irrational numbers, nice and pretty. Let's see. Okay, one more quick application of the quadratic, and it gets us into a little bit of simplifying. We'll go ahead and solve x squared plus 4x plus 1 equals 0 using the quadratic. With we already have one side set to 0. You do want to make sure you have that if you're solving using the quadratic. So we'll go ahead and move that 1 to the other side. And then we want half of 4 and square the result. And we'll add 4 to both sides. My apologies. That is if we want to complete the square. So I do encourage you to try this one, completing the square. See if you can finish that out using quadratic formula. Our b here is a 4, so opposite of that would be -4. b squared, 4 squared is 16, minus 4 from the formula, times 1 times 1, all over 2 times 1. So x is -4 plus or minus square root of 12 all over 2. Now notice 12 is not fully simplified there. We do have a nice, neat, pretty perfect square hiding under there. 12 is built out of a 4, which is a perfect square, and a 3, which is not. So -4 plus or minus 2 root 3 all over 2. And notice one more little bit of simplifying we can do on this. We can factor a 2. So then x would be -2 plus or minus root 3 for that one. So you will occasionally have some simplifying under a radical to do. If you're using a calculator and you put something like square root of 12 in it and it spits out a 2 root 3, you are not permitted to use that in this class. That would be considered a symbolic manipulator. Let's see. And the last one type that we'll hit is before absolute values. Moving on to absolute values, quadratic in form, so something of the form maybe x to the 4th minus 8x squared plus 12 is equal to 0. That would be quadratic in form. So strictly speaking, not a quadratic. We have a 4th power, not a 2nd power as our highest term. However, we can do a little u substitution, let u equal x squared, and then we have u squared minus 8u plus 12 equals 0. That one is factorable over the integers. So u minus 2 by u minus 6 is worth 0. That will multiply to 12, add to -8. So either u minus 2 equals 0, and you can either use the union symbol or write the word or if you're worried about getting it confused with the letter u that we're using in this, or the x, u minus 6 could be equal to 0. So u equals 2 or u equals 6. Don't forget though, if you make that substitution, plug the original back in and finish solving the problem. So these two can be solved using the square root method. So x is plus or minus root 2, or square root of x squared is plus or minus root 6, so x could also be plus or minus root 6. No non-trivial perfect square factors, no non-trivial perfect square factors, so we have 4 answers to that. Alright, and last but not least, from our days in Algebra 2, absolute value equations. So just run through a couple of those. So remember, absolute value is a distance. Distance, of course, can be 0 or positive. Distance can never be a negative number. So if I take the absolute value of something and get 5 as a result, my something could have been -5 or +5, so I have to set up both of those equations, and I connect them with the union symbol. So that just turned it into a pair of linear equations. So 3x is negative 12, so x is negative 4, or 3x is negative 2, x is negative 2/3. Both of those would give us a true statement in the original. If I try out the negative 4, we have negative 12 plus 7, which is a negative 5. Absolute value of negative 5 is indeed positive 5. 3 times negative 2/3 is negative 2. Negative 2 plus 7 is positive 5. Absolute value of 5 is still 5. So we could get a couple of answers. 0, though, is its own opposite, and this is the minimum value for an absolute value. An absolute value can be 0 or a positive. So this one would only have one solution, x equals 2. If they give me something like absolute of x plus 3 is equal to negative 1, and everything else is gone from the left-hand side, it's just an absolute value by itself equal to a negative, that one we can jump right to saying empty set. That is not possible, not in the reals, not in the complex numbers, not possible to do. Occasionally they let us play with nonlinear absolute values as well, something like absolute of x squared plus 9 is equal to 7. Well, then x squared plus 9 could be negative 7, or x squared plus 9 could equal positive 7. We had an absolute value equal to a positive, no problem. If there's other stuff hanging around on the same side as the absolute value, fix that first. Move that stuff out of the way. So x squared equals a negative 16. That one, we will just put a to be continued. We'll address that in A7 when we hit the complex numbers. Or x squared is worth negative 2, also a to be continued. So some problems that I recommend trying out if you're just doing the book problems. In section A6, I would just do 1 to 131 every other odd. If you're looking for some challenge problems, 137 to 142 are some interesting challenge problems as well. And we'll go over any questions that you run into on those at the start of next class. All right. Thank you all very much. If you have questions, please feel free to get in touch with me via email. Stay safe out there, and see you next time.